All right, so we've got the notes for section 5.3, the sum and difference identities. So we'll start with the cosine of a sum or difference. So the cosine, sum or difference of two angles, can be found by taking the cosine of the first times the cosine of the second. And then over here, if you notice, you got a minus plus symbol, which just means that the sign that appears here is the opposite of the sign that appears here. So if this is the sum of angles, you'd use a difference over here, and then the sign of the product. So I'll find the exact value of the cosine of 15 without using a calculator. So to do this, we need to write 15 in terms of angles that fall on the unit circle. So we need two angles to either add or subtract to 15. Now, since 15 is so small, we're probably gonna have to find a difference. So the two smallest angles I could use would be 45 and 30. So I'm gonna rewrite this as the cosine of 45 minus 30. And I'm just gonna follow this pattern. So this would be become the cosine of the first times the cosine of the second. Now, since that's a minus, my formula reverses it, plus sine of the first, sine of the second. Fill in all my zeros so we don't confuse those with radian. And then I can use the unit circle to get all these values. So the cosine of 45 is root 2 over 2. The cosine of 30 is root 3 over 2. Sine of 45 is root 2 over 2. Sine of 30 is 1/2. So this is root 6 over 4 plus root 2 over 4, or root 6 plus root 2 all over 4. And that is an exact value because I still have my roots there. All right, so prove the identities. So this is, we'll use the difference formula over here. So the cosine of the first, cosine of the second, reverse the sign, sine of the first, sine of the second. So the cosine of pi over 2 is 0, so this becomes 0 times cosine x. The sine of pi over 2 is 1, so that's all 0, so 0 plus sine x gives me just sine x. All right, so let's see here. This one, right. So we have to use a cofunction identity here. So this is the cosine of pi over 2 minus pi over 2 minus x. So it'll look like this. Okay, so cosine of the first, cosine of the second, reverse the sign, sine of the first, sine of the second. So the cosine of pi over 2 is 0, so this stuff all goes away. This is 1. So this is 1. And then this is a cofunction identity, so that's 1 times the cosine of x. So this whole thing is just the cosine of x, which is what we had in the first place. Okay, so then you get the sine versions of these formulas. So sine, they alternate, sine, cosine, and the sign in between is the same as the sign here. So I would do sine plus plus, or if this is a plus, that's a plus, so on and so forth. So these ones are actually going backwards, right? Each of the following expressions as the sine or cosine of a single angle. So since they're mixed, my final thing is going to be a sine function. That's my u, that's my v, so 22, 13. Sine matches, so plus in the middle. So this is the same thing as the sine of 35 degrees. So double cosines mean I'm dealing with the cosine function. So first is pi over 3, whoops, don't know that. Second is pi over 4. Cosine takes the opposite. So since it's plus in the middle, that's minus. So I need a common denominator of this, so that's cosine of 4 pi over 12 minus 3 pi over 12. So this is the cosine of pi over 12. So I've got, okay, so double sine, double cosine. So they're in the wrong order, so I'm going to pull a -1 out front, which lets me flip this stuff. Oops, that's going to become minus. The sign becomes negative when I pull out the negative. So I have this. So -1 times, so double cosine means I start with cosine. First angle is x, second angle is 2x. Since it's minus here, this becomes plus because cosine takes the opposite. So this is negative cosine of 3x. Alrighty, example 4. Prove the reduction formulas. Okay, so we've got to use our sum and difference formulas. So double sign or sine of a sum is sine of the first, cosine of the second, and then the same thing, and then cosine of the first, sine of the second. Now the sine of pi is 0, so that all goes away. The cosine of pi is -1, so this gives us negative sine x equals negative sine x. Similar thing down here. So cosine is cosine of the first, cosine of the second, opposite, sine of the first, sine of the second. So the cosine of 3 pi over 2 is 0, so that whole term goes away. The sine of 3 pi over 2 is -1. We've already got a negative out front here, so this is just sine x. Negative sine times -1 is positive sine, which is what I was going for. Okay, and the last one here, we've got the tangent. So the tangent, you've got a whole bunch of different formulas. So tangent is defined as sine over cosine, which is where this comes from. And then this is the expansion for sine, the expansion for cosine, and you can actually do some simplifying, and eventually you come down to this formula. So prove the reduction formula, tangent of theta minus 3 pi over 2 is equal to the negative cotangent. So the rule for tangent is tangent of the first. Then here's, if you notice, it's plus minus, which means just the same thing, tangent of 3 pi over 2, all over 1, and down here's the opposite, so minus plus the tangent of theta times the tangent of 3 pi over 2. So let's see what we can do here. I actually don't think we can use this formula because at 3 pi over 2, the tangent, 3 pi over 2 is down here. The tangent is undefined, so I actually can't use this formula. I've got to go back a step and do this one. So it's sine theta cosine 3 pi over 2 minus cosine theta sine 3 pi over 2, so that's the top, all over on the bottom, cosine theta cosine 3 pi over 2, plus, because it's the opposite for cosine rules, sine theta sine 3 pi over 2. So let's see what we got. So the cosine of 3 pi over 2 is 0, so this whole term goes away. The sine of 3 pi over 2 is -1, so this numerator is negative cosine theta times -1. Because all that stuff is 0. All over on the bottom, once again, cosine of 3 pi over 2 is 0. It goes away. The sine of 3 pi over 2 is -1, so this is the sine of theta times -1. So my -1s can cancel, so I have negative cosine theta over sine theta, and cosine divided by sine is the cotangent. Which brings us to the end of the section.